Introduction to Spring MVC. Spring MVC is a module of the Spring framework that provides architecture for developing flexible and loosely coupled web applications. It follows the ModelAndView controller design pattern and is built around a dispatcher servlet that dispatches requests to handlers with configurable handler mappings, view resolution, locale, time zone, and theme resolution, as well as support for uploading files. In the provided code snippet, we declare a class HelloController, annotated with @controller, indicating it's a Spring MVC controller. The hello method is annotated with @requestMapping to map web requests to /hello URL to this method. When this URL is accessed, it invokes the hello method, which instantiates a ModelAndView object with a view named hello and adds a message to the model. The returned ModelAndView object includes the name of the view and the data to be rendered, which will be used by Spring MVC to generate the final response. MVC Architecture. MVC stands for ModelAndView Controller. It is a design pattern that separates the application into 3 interconnected components to separate internal representations of information from the ways that information is presented to and accepted from the user. Within the context of Spring MVC, Model encapsulates the application data and business rules. View is responsible for rendering the model data, and it generates HTML output that the client's browser can interpret. And Controller processes user requests, builds an appropriate model, and passes it to the view for rendering. Spring MVC provides a cohesive framework for MVC architecture by using annotations and configurations to map user requests to controller methods, manage dependencies, and integrate with other Spring features. Defining controllers. Controllers in Spring MVC are Java classes that handle incoming HTTP requests. They are annotated with @controller, and their methods use @requestMapping to specify the URL patterns they handle. Each method can return a view name, a ModelAndView object, or write directly to the response body. The code defines a Spring MVC controller called myController. The class is annotated with @controller, indicating it's a controller component. The greet method is mapped to handle GET requests at /greet URL through @GetMapping. It accepts a model object, adds an attribute to it, and returns the view name greeting, which the ViewResolver will use to render a response. RequestMapping and GetMapping PostMapping. The @requestMapping annotation is used to map web requests to Spring controller methods. It's a versatile annotation that can handle different types of HTTP methods and requests. In the code, RequestMapping is applied to the greet method, mapping it to handle GET requests for the path /greet. When this URL is accessed, the method returns the view name greet, and a message hello world is added to the model, which the view can use. Request parameters, path variables. In Spring MVC, request parameters are retrieved from the query string of the HTTP request. They are commonly used for filtering results or passing data. The @requestParam annotation is used to bind request parameters to the method parameters in a controller. In this example, the parameter name is extracted from the request with an optional default value of world. It's then passed to the view named greeting. Data binding. In Spring MVC, data binding is a process by which the HTTP request parameters are automatically bound to the Java beans or objects in a model. It simplifies the development process by directly mapping request parameters to object properties. In this code snippet, the @model attribute annotation is used to indicate that a parameter should be populated with data from a web request. The user object named user will automatically have its fields filled with the corresponding request parameters that have the same names as the user class properties. Form handling. In Spring MVC, form handling is facilitated using the standard Web MVC framework. This involves creating a form in a view, such as a JSP or Thymeleaf template, binding form fields to a Java object, validating user input, and processing the form submission in a controller. Model and ModelAndView. In Spring MVC, the model is used to pass data from controller to the view. It's a map that can hold data the view may require. Here, Model is an interface, allowing for the abstraction of the implementation. The addAttribute method is used to add the string Hello World into the model with the key message. The data can then be accessed in the view by this key. The method returns the view name as a string. ViewResolver and View templates, Thymeleaf, JSP. In Spring MVC, ViewResolvers help the dispatcher servlet to resolve views by name. When a controller returns a view name, the ViewResolver maps it to a specific view implementation. Two common view technologies are JSP, Java Server Pages, and Thymeleaf. The provided code is a configuration class for Spring MVC that declares a ViewResolver bean. This specific ViewResolver is an internal resource ViewResolver, which resolves view names to JSP files within the swebinf views directory. For example, if a controller returns a view named home, this ViewResolver will translate it to /webandview/home.jsp. Static resources handling. In a Spring MVC application, static resources are assets such as JavaScript, CSS, images, and other files that don't need to be processed by the server. Spring provides various ways to handle these resources efficiently. One common approach is to map a URL pattern to locations where these static resources are stored, so that the web server can handle requests for these resources directly. The provided code snippet is an example of a Spring MVC configuration class that implements WebMVC configurer. The addResourceHandlers method is overridden to define how static resources should be served. It maps all URLs /stat to the resources located in the class path directory /static. This means that if you request /static.js app.js, Spring will look for the file in srsmain/resources static.js app.js. Exception handling in Spring MVC. Exception handling in Spring MVC allows you to handle exceptions that occur during the execution of your web application in a clean and global manner. The framework provides several ways to manage exceptions, including the use of @exceptionHandler, @controllerAdvice, and response status annotations, among others. The provided code snippet demonstrates two ways to handle exceptions in Spring MVC. The @controllerAdvice annotation marks the class as a global exception handler. The @exceptionHandler indicates which exception type the method should handle. The first method handles generic exceptions and returns a response entity with the error message and HTTP status.internal server error. The second method uses both @exceptionHandler and @response status annotations to deal with a no such element exception, and directly specifies the response status code without using response entity. This method returns the error message as a response body with a HTTP status.notfound status. File upload and download. Spring MVC supports file upload functionality by integrating with Apache Commons file upload and provides multi-part file interface to handle HTTP multi-part requests. Below is a code snippet showing a simple file upload controller using Spring MVC. In the provided code snippet, a Spring MVC controller named FileUploadController has a method, handleFileUpload, which is mapped to handle post requests to /upload. The method accepts a multi-part file parameter, annotated with @requestParam. This indicates that the method expects a file upload identified by the file form field. Within the method, you would typically implement the logic to save the uploaded file to a server directory. Data access with JDBC. Spring Framework simplifies data access operations with JDBC by providing a template called JdbcTemplate that handles the creation and release of resources, such as creating and closing connections, statements, and result sets. This allows developers to focus on the SQL queries and the extraction of results without worrying about boilerplate code related to resource management. The provided code snippet shows a basic usage of the JDBC template in a data access object, DAO, for querying a hypothetical employee's database table. The employee DAO class is initialized with a DataSource, which is then used to create an instance of JdbcTemplate. The getEmployeeById method illustrates how to execute a query that fetches a single record from the database. It uses query for object with the SQL query, the required parameters, in this case the employee's ID, and a row mapper to convert the result set into an employee. Object. Configuring a data source. In Spring, The DataSource interface is the key to integrating with a database. It represents a connection pool and provides the necessary connection to perform database operations. Configuring a data source typically involves specifying the URL, username, password, and driver class name of the database you want to connect to. Below is an example of how to configure a data source bean in a Spring application using Java configuration. The provided code snippet is a Java configuration class marked with @configuration, indicating that it will be used by Spring to configure beans in the application context. The data source method is annotated with @bean, signaling to Spring that the method will return an object that should be managed by the Spring container. Inside the method, we instantiate a driver manager data source and set properties such as the driver class name, the database URL, username, and password. This configured data source bean can now be automatically used by Spring's data access components. Using JDBcTemplate. Spring's JdbcTemplate is a tool for simplifying database interaction and for converting JDBC operations into Spring-based exception and transaction management. It gets rid of the boilerplate code traditionally associated with database connection and resource management. This code snippet shows how to use JDBcTemplate to query a database and map the result to a Java object. The JDBcTemplate.queryForObject method is used to execute a SQL query with parameters and map the single returned row to an instance of the employee class using a bean property row mapper. Exception translation. Spring provides a mechanism to translate technology-specific exceptions, like JDBC SQL exceptions, into consistent, unchecked exceptions. This is part of its broader data access exception hierarchy. The data access exception hierarchy lets your code catch exceptions and react without having to know the details of the specific data access API that threw the exception. In this code snippet, data access exception is caught in the catch block, which is the superclass for all data access-related exceptions in Spring. You don't need to write different catch blocks for each specific SQL exception. Instead, you use Spring's exception translation feature that has already translated JDBC exceptions into a more generic data access exception. Spring Transaction Management. Spring Transaction Management is a powerful abstraction that allows you to manage transactions programmatically or declaratively. It provides a consistent programming model across different transaction APIs such as JTA, JDBC, Hibernate, JPA, and others. Declarative transaction management is often used for its simplicity and less boilerplate code. The code snippet demonstrates the use of the @transactional annotation in Spring. By annotating a method with @transactional, Spring automatically starts a transaction before the method is invoked and commits the transaction after the method completes. If a runtime exception is thrown within the method, the transaction is rolled back. This annotation abstracts away the underlying transaction management code. The method updateTransactional method can contain business logic that requires transactional behavior, like updating multiple database records atomically. Declarative transactions using @transactional. In Spring, the @transactional annotation declares that a method should be executed within a transactional context. This is part of Spring's declarative transaction management, which allows you to manage transactions without having to manually start and commit transactions. The code snippet defines a method updateEntity annotated with @transactional, which indicates that this method should run within a transaction. When this method is called, Spring will start a new transaction before the method execution and commit the transaction afterwards if the method completes without throwing exceptions. In case of any exceptions, the transaction will be rolled back, preventing partial data modifications. This automatic handling is enabled by Spring's AOP proxy mechanisms that intercept the method call and apply the appropriate transactional behavior. Spring Data Repositories. Spring Data Repositories are high-level abstraction for data access layers. They greatly simplify the implementation of data access layers by reducing boilerplate code and enabling a more rapid, streamlined persistence layer implementation. In this code, we define an interface called user repository that extends JPay repository. This interface manages user entities with long as the ID type. By extending JDBcTemplate, it inherits several methods like save, delete, and find all. Additionally, we declare a custom method findByEmailAddress to fetch a user by their email address. Spring Data intelligently infers the query from the method name, so we don't have to write the actual SQL. When the application runs, Spring Data automatically provides the implementation of this interface. Spring Data JPA integration. Spring Data JPA is a part of the larger Spring Data family that makes it easier to implement JPA-based repositories. It reduces boilerplate coding for database operations and supports a rich set of data access APIs with flexible query methods. We'll now look at a simple example of integrating Spring Data JPA to perform CRUD operations. The code snippet defines an interface employee repository that extends the Spring Data CRUD repository interface, which provides generic CRUD operation methods for the entity class employee with the ID type long. By extending CRUD repository, Spring Data JPA will provide implementations for methods such as save, find by ID, find all, count, delete by ID, and more. The @repository annotation indicates that Spring should treat this interface as a repository bean that can be injected into other components. With just this interface, Spring Boot can auto-configure a bean that implements it, thus simplifying data access layer coding substantially. Query methods and @query annotation. Spring Data repositories allow you to define query methods on your interface that Spring will automatically implement for you. You define the query by simply declaring the method on the repository interface, and Spring will derive the query from the method name. The code snippet defines a repository interface for user entities. The findByLastName method is a query method. Spring Data passes the method name to create a query that selects users by their last name. Spring Data REST. Spring Data REST is an extension of the Spring Data project, which aims to simplify building hypermedia-driven REST web services on top of Spring Data repositories. It abstracts away much of the boilerplate required to create a RESTful service. The above code snippet demonstrates how to expose a simple CRUD, create, read, update, delete, RESTful service for a user entity using Spring Data REST without writing any custom controller code. The repository REST resource annotation directly binds the user repository to /user's path, allowing basic operations like get, post, put, and delete on the user entity.